About the key, these questions here. Says find the exact value. So here's the thing with your calculator, exact values are not likely, especially depending on the type of calculator you use. So what we do here, remember the sine inverse. The sine inverse is only going to be appropriate in the third and fourth quadrants, right? Okay. So when they give me this information, sine inverse, the input has to be a number such as this, and now we're getting so that if you remember about the domain of your sine inverse is between -1 and 1, and the output is going to be between -90 and +90. Because that's the domain. I guess just like we remember we talked about the sine function being like that wave type thing, and then we had to cut down the original domain of that and then reflect it over the y-axis. So it was this here. Let's see here. Maybe let's talk about it this way first. If I've got if I'm just going to use the sine function. The sine function of some angle is equal to opposite over hypotenuse, right? Okay, now we know we can be in like several different quadrants here with this. So so this number could be positive or negative, right? Opposite side could be positive or negative. The hypotenuse is going to have to be positive though, right? So this number could be positive or negative as a quotient. But the hypotenuse, physically, the hypotenuse is always the longest side, right? So your denominator is always going to be biggest, correct? Okay. So if my denominator is always going to be the biggest, then a number divided by something that is bigger than it is always going to be less than 1, correct? So it's 1 to 0 is that value there. But because we can be in, so 0 or that opposite side could be a negative, that quotient here, this quotient can only fall between -1 and +1, okay? Our angles, because our angles are going to be in a right triangle, correct? That's what SOHCAHTOA is for, angles in a right triangle. So that theta right there, that theta can only be numbers that are between 0 and 90 degrees. Does that make sense? Because it's the acute angle of a right triangle, okay? And we've already got 90 degrees eaten up, so there's only 90 degrees left for theta and that angle there. Now, because it could be in a fourth quadrant in this case, we also say that it could go to -90, okay? Because like I said, so basically this stuff here from opposite over hypotenuse being less than 1 and up to 0, that would give me something from 0 to 90 degrees back, okay? This here would give me something from -90 degrees to 0 back. Does that kind of make sense? So if this is the output for sine function, this is the input for the sine function. So when we go sine inverse then, so sine inverse of O over H should give me then theta. Remember that now your input is a number between -1 and 1, and now your output is going to be an angle between -90 and +90. So maybe that's maybe the right triangle way of viewing what we did with you remember the discussion where we went sine of x, but said that thing's not 1 to 1, so we had to cut that down between -pi/2, which is -90 degrees, to +pi/2, which is +90 degrees. So we need to look at just that red section then. And that red section is 1 to 1. So now if I take that red section and invert it across the line y equals x, we get that blue section, and that blue section then is our inverse function. And if we look at the y values for that, like y equals pi over 2 or 90 degrees. That's the last y value we see on that blue curve. And then negative pi over 2 is the first y value we see. So there's my range of that curve. And you see that the domain is only going between negative 1 and 1, right? So those are maybe two ways that we can validate that information. So then asking the question, if sine inverse of radical 3 over 2 is an opposite divided by hypotenuse, and it's positive, and I know that I'm only going to get an output value if this thing is positive from the first quadrant. Sine is positive in the second quadrant, right? But the second quadrant is beyond that 90 degrees that we know we should be getting back, right? The second quadrant is 90 to 180. So I know when this is positive, I should be looking at a triangle here in the first quadrant. The theta that I'm solving for would be that angle there, okay? And if it's opposite over hypotenuse, opposite is radical 3, hypotenuse is 2, Pythagoras tells you that that distance there is 1. And when I have a 1 radical 3 and 2 relation between three sides, where 2 is obviously your hypotenuse, right? That's a 30, 60, 90 triangle. Right? And that's one thing that I think is something we need to commit to memory. Now I don't have 30, 60, 90. You guys usually put n on there, right? But what if n was 1? Doesn't leave me just 2, 1, and radical 3? So then that helps me realize, okay, well then that angle, what is always across from the n radical 3 side in a 30, 60, 90? It's always a 60-degree angle, right? That's got to be the radical 3 is the middle value there, the middle dimension. So 60 is the middle angle in 30, 60, 90. That kind of makes sense? Blaze?
No, you're going to give us a paper with like equations on it?
Yeah, I'll give those to you. Like sine squared plus cosine squared equals 1, that kind of stuff?
Yeah, and then like angular speed and linear speed.
Yeah, I'll give those to you too.
What's going to be on the paper?
Yeah, I'll give you all the formulas. So the second one is cosine, okay? So cosine, all right, is only going to give numbers now back between 0 and 180, okay? And it's not as easy to kind of explain this one with the output idea with the triangles. And really the most direct, most appropriate way to talk about inverses, and we'll talk about it again in chapter 6, is from the function curves, okay? Cosine inverse cosine, for it to have an inverse, you need to restrict the curve from 0 to pi, or 0 to 180, and then it becomes 1 to 1, okay? So that's why these results here are only going to be from the first and second quadrant. But it's positive, and I know cosine in the second quadrant would actually be negative, right? Okay, because the adjacent side over here would be negative. So I know this is again being in the first quadrant, so I get 1 there and I get 2 there, and this would be radical 3 again, but they're asking again for that theta. Is that not the same picture as what we had here? So sine inverse of radical 3 over 2 is the same thing as the cosine inverse of 1/2. And now here's the reason. Well, so when we talk about theta here, this is the adjacent 1 over 2, right? Okay. And so this number here is what we had to find with the Pythagorean theorem. Over here, we had to find that 1 with the Pythagorean theorem. Here we're going to find radical 3. But when I see 1, radical 3, and 2 show up, and 2 being the hypotenuse, then we know that we got a 30, 60, 90 triangle, and we just have to figure out that, okay, theta is across from radical 3 in this case, so theta has to be 60 again.
So what do you mean?
Huh? Yes, 0 to pi. Well, the domain, the cosine inverse domain is negative 1 to 1. Because remember, the domain is the thing that we can put inside the parentheses there. It's the argument. So that number is going to be between negative 1 and 1. The output or the range is 0 to 180. Yes.
Why was the homework so hard?
Yeah.
Well, 5, 6, and 5, 5?
Yeah.
What's hard about it?
Number 4 on 5.
A lot of it, dude. It was impossible.
Number 4 on 5.
Maybe we want to throw my
Like,
computer
I don't
in there and
believe
shoot
that.
12 gauge.
Number 4 on 5, 5 is the ambiguous case.
You don't say.
I do say.
I don't like that.
Well, that's because it's a pain in the butt.
And then on 5, 6, they asked me what about a parallelogram. It's more than 3 sides. Am I wrong, big dog?
Huh? Big dog?
Parallelogram.
Yeah, what about it? You don't know what a parallelogram is?
It's got.
What's a diagonal parallelogram do?
What's it?
Splits it into 2 triangles.
But it says one angle is 40. How do I know which angle is 40?
Well, when I draw a parallelogram, it's probably going to be the one that's acute. It doesn't matter, though.
Yeah, but which way do I split the parallelogram?
Doesn't matter. Which question is this?
This is 8, but there's a lot I got questions on. This is 5, 6, 8, but we need to talk about 5, 5. I didn't do like half of it.
Okay, so somebody said 5, 5, number 4.
Are you going to keep this due Saturday night because it's been that way for a while?
No, I'm going to make it due Tuesday.
Oh, cool. Thank you.
But it's going to be Tuesday before school.
Dude, I'm gonna have so many questions. I don't understand. 9, 10.
No, because I want you to use this to prepare for the test.
12.
All right, so we got that, right? So if you're struggling with this, did you draw a picture?
Yeah.
Okay.
Wait, what number is this? 4?
4.
I got this right.
So I draw my picture. Angle A. Side A. C is 46, right? All right, so if I look at that stuff,
So where's B2 and C2?
excuse me,
Where's B2 and C2?
they're not there yet. So triangle 1, we're gonna first see if triangle 1 actually, with the information given, works. So we're gonna find a measure. Let me just do this. I'm gonna write measure of angle A is 39 degrees, right? Do I know the measure of angle C yet? Nope. Do I know the measure of angle B? Nope. Do I know lowercase b? Which would be this side here, right? Okay. So I gotta find those things. Okay. And so we attack this using law of sines. Now, if you look at the information that's provided, you've got an angle and 2 sides, right? Is that angle between the 2 sides? No, so this is angle side side. That's what we're trying to get at here. And that means it's the ambiguous case. So in regards to finding angle C, and some people say, well, how did you know to find angle C? It's the only thing I can find. Because when I use the law of sines, I've got to have only one unknown in my equation, right? Well, if I try to find B right away, capital B or lowercase b, they're going to be paired in the same ratio, and that would be then 2 values that I do not know, so I have 2 unknowns there. So the only other value that I know there is what? That I have not used in this proportion yet. C, 46, right? So 46 needs to go there, and then opposite it is sine of C. So capital C angle here is the missing component that we're going to solve for. So cross multiply. So my hope is it's not the algebra. Okay? You cross multiply. So I'm going to go through that fast. 46 sine of 39 is equal to 35 sine of C, right? Divide both sides by 35. So we get 46 sine of 39 over 35. That's going to equal sine of C. How do I get capital C out of there? Okay, arc sine, sine inverse. So we're going to go 46 sine of 39 in here over 35. That is going to equal capital C. Okay. So we're going to do that math. Grab our calculator, whatever you want to use. I prefer Desmos. I prefer Desmos, and I know on your ACT, you're going to have to use your TIA 384. There's a way to do some of this stuff on those calculators. We've used the STO button before, so store button, right? Okay. And I'm going to use that. I like Desmos because it allows me to mitigate as much rounding error as possible. So I'm going to go arc sine of 46, sine of 39, divided by 35, and I get that measurement right there. Make sure you're in the right mode, okay? And sometimes if you're in the wrong mode, your answer might be, it just happenstance, your answer might be very close within decimal places or within several whole numbers of the actual answer, but you're still in the wrong mode. Okay, so make sure you know what programs you're using. Your TIA 384, if you use it on your computer, depending on how you got your settings set up on that, when you close it out, it might reset your calculator and put you into a default mode of radians. Let me answer this. You probably lost your key. Should be either still in it or check my jacket that I was wearing. Yeah.
You know what Cole said?
What?
Cole said that she went to his house.
Did she?
And I said,
She was there again? That's my mom.
She's calling from beyond.
Nah, that's my wife. She lost her keys.
hey, how was that thing you went to yesterday? Or 2 days ago?
I really didn't learn anything new.
Oh.
Like I already knew some of the stuff, like most of the stuff they talked about. What sucked about though is, like I went in and they told us we were in the wrong building because on the sheet they gave us the wrong directions. So we went back and they said just drive around into the other building. So when I first went in, I didn't have my bag with me, my computer bag. So we leave. I'm like, we go in the second door. I'm like, okay, I should probably maybe I might need my computer. So I take my book bag in, all my stuff, and maybe I thought maybe I had some downtime, maybe I can do some work. Take it in with 8 hours. They talked to us for 8 hours and never took my computer out. So at the end, I want a book. I'll never read it. And like I just grabbed my book and I left. Left my book bag underneath my table. Had this laptop in it that Mr. Goff just gave me. It's probably a $1,500 laptop.
I thought it was your mom.
So, like I don't realize this. Faith asked me to extend an assignment for her, so I was getting home Wednesday night about 9:30, and I went looking for my laptop and realized that my book bag was not in my car. So, it was at Owens still. So,
Oh, that's
community college in Findlay. That's where I had to go.
that's far away.
So, I call. They're closed. Security's gone. Whatever. So I call back yesterday morning, and you call Finley's office, and it always takes you to Toledo's office, which is the stupidest thing ever. And then the lady says, "Okay, well, I'll transfer you down to Findlay," and she transferred me to Findlay, and she instantly hangs up on me. So I call her like this. She does this 3 times. I'm like, "Just give me the phone number. I'll call him." So I call him. Guy's like, "Yeah, we'll go look for it. We'll see if it's there." Calls me back in a half hour. "Hey, we didn't find anything. We scoured the classroom. We looked at several times, didn't find anything." I'm like, "Okay." He's like, "I'll keep your name in case it shows up." So I mulled over it for most of the day yesterday. I'm like, "Man, that bugs me. I don't know what I'm going to do without a computer, and I don't know if is school going to make me pay for it. Do they have insurance on the teachers' computers?" So I was just sitting there, and my daughter had to go to the piano lessons in Findlay, or not Findlay, Bluffton. So I got her ready for that. Her grandma took her to that, and I just jetted up to Findlay, and I get up there, and there's nobody in the parking lot. This place is vacant, completely shut down. And I'm like, there's no way that this door is unlocked. So I walk up there, pull the door, it's unlocked. So I got in. And so I'm in there, and this place has got like so many security cameras, and I'm walking, there's nobody in there. So I'm walking to the classroom we were in, or lecture hall or whatever, and I get there, and I'm about to open a door, and I hear all these little kids laughing. I'm like, what's going on? So I don't open the door right away, and I just kind of listen. It sounds like there's like a daycare or something going on in there, and they're watching Frozen. And so it was like right at 3 o'clock. I'm like, this thing can't be like if it's maybe a class or something. I don't know. Maybe it's over at 3. Maybe they're done at 3. So I wait till 3, and they're not done, and I can hear Frozen. I've watched Frozen about 1,000 times on my own. Not because I have daughters, just because that's what I enjoy doing. So I know that the movie's like not close to being over. So I'm like I'm just sitting out in the hallway, and like I'm thinking somebody's looking at security cameras and seeing this guy sitting outside this hall with like 30 little kids in this room, and they're thinking, this dude is a creep. Like, what's he doing? So I'm like, you know what? I drove up this far. This bag could be sitting in this room. So I just open the door like slightly, and it's pitch black in there. And so when I open the door, like it just illuminates the whole room. And like 30 little kids just look at me, and then they look back at Frozen. And like it's like they didn't care at all. But there's an adult in there, and I go up to her, and like she had no like if I'm in charge of 30 kids in a room, and some dude shows up in a big Carhartt jacket and scruffy looking, and I'm concerned. She's just sitting there Facebook, and she just looks at me. I'm like, hey, I'm gonna look around and see if I left my book bag here. So I go back to my seat that I was sitting in, and sure enough, my book bag's right underneath the desk. And so I was half tempted to go over to the security office and ask them if they found it yet. But I had to get my daughter from piano, so I didn't have time to go be a jerk. But I was pretty. It was a trip worth it because I got obviously everything back. But
Did you get like Chick-fil-A too?
no, I didn't have time. All right, so going through this, we get that stuff there. So that's the angle, right? 55.8. Okay. So angle C, 55.8 degrees. Now I'm going to highlight that. Okay, because that is the angle right there that is going to be the key to telling me if there's a second triangle. Okay. So I always make note of that angle. Highlight it, put a box around it, circle it, do something. Because you're not going to usually mess with that until you solve for the rest of the triangle that's currently being generated here. Does that make sense? We gotta find angle B, and I gotta find lowercase b, and then we'll see if triangle 2 actually works. So if that's 55.8, if that angle right there is 55.8, can I find what angle B is?
Yes.
Okay, so 180 minus 39 minus that would give me angle B, right? Does that make sense? Okay, and that's just the triangle angle sum theorem. If you know two angles, subtract them away from 180, and you'll get the third angle. So angle B for us, 85.2. Okay. Now, do you guys want to solve for lowercase b? Do we need to be able to do that, or show how to do that, or do you know how to do that?
We know how to do that.
No.
You're okay solving for distance b?
Yes.
How you do that?
Oh my gosh.
So I'm gonna say sine of 39 over 35. Okay. Now I had a choice there.
I thought he was kidding.
39 over 39, 35. Or use those two. Why did I choose the green ones?
Because they're like not rounded.
Because they're not rounded. Okay. Now, provided that, I think the question is say round everything to the 10th place. It doesn't matter if you use this one and that one. I just want to write 55.8. I would use like 55, because I think it was like 55.802 or something like that. I would use like 3 decimal places, or 4. Does that make sense? Okay. I had several people email me over the last couple days about, hey, I have trouble I'm getting like really close to the right answer, but it's saying it's wrong by like a decimal place, like a 10th place, something like that. And my thought is that they're probably rounding intermediate values too far to where it then impacts what the desired result is. Okay. So if I can mitigate rounding error, I'm going to. If I can avoid it, I'm going to. Okay. So the next thing then to find B, so B has got to be my unknown right here, right? I got to find that lowercase b. Well, don't I know that this angle here is 85.2? So sine of 85.2. Now that is rounded, right? 85.2 was rounded. So it's unavoidable here with the way I write this stuff. But when I grab my calculator, I'm not going to use that number. I'll show you what I mean by that. So a lot of times when and I think for the most part, you guys a lot of us are doing this. Like when I write something down, when I grab my calculator, if I've got a better way of getting that 85.2, instead of using 85.2, I'm going to use my calculator to do that. So I might write 85.2 to remind myself of what goes there, but I might actually write the entire number that is actually being represented by the 85.2. Does that make sense? I might not do any rounding with that. I'm just reminding myself with what I wrote down of what goes there. So here's the idea. In order to, so I've already got this 85.2 on Desmos here. I'm just going to define that as lowercase a. Use whatever letter you want to. But now instead of going, when I go 35 sine of 30 or 85.2 divided by sine of 39, I get that number there. Or if I go 35 sine of, instead of 85.2, I type in a, I get that. You see that in this case, the 85.2, or using 85.197326663 does not affect the tens place, right? It doesn't come into the 10,000s place that really end up having an impact. Okay? But my fear is that if you round this so bad, okay, and maybe you had other values that were rounded that got you that number, then that 0.4 is going to be, there's going to be error in that. You might get like 0.5. Does that make sense? So when you're rounding, when you're using, this is the law of sines always does this, when you use intermediate values to come up with an overall answer, make sure that you understand how you can minimize the error. Okay? So that's how I find B. Now, here's the issue then. Is there a triangle 2?
Yes.
Okay, if there's a triangle 2, it has to have measure angle A to be 39 degrees, right? Measure of angle C, and this is why we highlighted that number right there. Yeah, that was the first angle we found. If triangle 2 exists, then angle C is going to be the supplement of 55.8. Angle C is going to be the supplement of 55.8. Okay? So what I'm going to do, say it again. No, because when we first use the law of sines, it gives us that angle right there, right? So going back to, let's see here. Let me see where it says, there you go. Remember this image here? So the law of sines initially is going to give us this angle where my cursor is. Okay? If a second triangle exists, it's going to be that angle where my cursor is. Okay? Well, the way these angles work is that, so let me color code this real quick. If I color that one blue and that one purple, or pink, whatever color that is, when I do the second triangle, this ends up being the pink one, and that ends up being the blue one. But they're the same angles. I mean, they're the same numbers, same measurements. So that exterior angle actually on the second triangle becomes the interior angle. And it's just the physics of the triangles that it has to be that first angle that we found. It's not going to be this top angle that is going to be a supplement of. So it's always that first one that we find. So I'm going to take 55.8 and subtract that from 180. And that was, let's see here. So that number right there was 55.8. So I'll go 180 minus that, so I get 124.197, right? 124.197. Okay, now here's my question. This is how we determine, so this was the supplement of that angle, and this is how we determine whether a second triangle actually exists. What's 39 plus 124?
Not 180.
Not 180. Does it exceed 180? No, it's less than 180, right? And that's what we're looking for, okay? If it's less than 180, what's that tell me that we have for angle B? We have enough room in terms of angle measurements for a third angle. If it was, let's say that sum ended up being like 182, we've already blown up the triangle, right, with two angles, okay? So we're looking for that sum to be less than 180. It is. Does that give me something approximately like 16 degrees? Did you do that, Cole? Did you do that sum right there, 39 and 124?
I thought it was,
Did you add that together? 16 or 17 degrees is what would be left over then for angle B. Okay. And now once I have that, obviously now, think about this, angle B is now not 85.2, but it's 17. So this segment here is going to intersect this segment down here differently, right? So eventually that distance B is going to be different. So then you got to go find distance B again with that information from that red triangle. Does that kind of make sense? So first thing you do, so to see if a second triangle exists, you take the supplement of the first angle you found. And then add that to the given angle in the picture. If that is less than 180, you have leftover angle measurement for the third angle. The second triangle will definitely exist. If it's greater than 180, second triangle does not exist. Okay. Chuck? What's confusing, Chuck?
So what's like the second triangle gonna look like?
I mean, it's going to be obtuse. So this triangle here,
That's the first.
yeah, but is that even? I mean, that's not accurate, right? So I'm not. I think that's what what a lot of people get in their head. Like when I draw this, like I don't know, my eyes, your eyes, you can't draw a 39-degree angle, right? So I'm just drawing the triangle just as a graphic organizer to think about: is it angle side side? What things can I find first? What things do I need to find as I move throughout the problem? I'm not drawing the picture in an effort to be to scale, okay? But you know, if I want to look at, maybe we'll do something like this real quick. Let's look at, so 39 degrees was there, right? Now the distances are different, but it should still be the same kind of relationship, okay? So the first triangle that I drew should have been the yellow one, something similar to the yellow one, right? The second triangle I get then, because one of the angles had to be obtuse, right? It was 124. The second triangle is going to be like the one on the right. Does that make sense?
Number 9.
Okay.
B2, same way as B1.
Find B the exact same way you found B with triangle 1. What else?
Number 9.
Number 9.
And 5, 5.
Oh, come on, man.
What do you mean?
What do I mean? What do you know about angle X and...
Listen, I know how to find the one angle.
X is angle A, and Y is...
So what's the relationship between that angle there and that angle there? They're the same.
Okay, never mind. I don't need help. I don't need help.
Make sure you answer the second part correctly. I think in mine this is like 49 degrees. So then what is that angle right there then?
180 minus 31 minus 49.
Okay, so it's 100 degrees, right? This is 10 miles. AB is 10 miles. So now do I have 31, 100, 49, 10. The first part here is to find X, right? Can I say sine of 49 over X equals sine of 100 over 10. Okay. The second question asks you to find that distance. That's what I want you guys to make sure that you're paying attention to. But when they ask you to find that distance, I already know this one's 7.66 from what we found in the first part. Is this just a SOHCAHTOA question then? With that right triangle to find that altitude? Others? 155? So this isn't it's not a huge concern or issue. I'm not going to ask this. But some people prefer to like know these things. These are the four congruencies that we know should exist from geometry. Okay. There's another one called hypotenuse leg, but that is the angle side situation for a right triangle. So it's asking you which cases do we use for the law of sines. Okay. And this is how I remember this. Law of cosines. And I don't know why this sticks with me more than law of sines does, but I remember law of cosines are these two. So law of sines is everything else. So I'm going to eliminate those two, and now I've got the two that work with law of sines. Is that going to make sense? You can also use law of sines with angle side as well. I don't know why I don't have that one in here. But it says which of the cases listed can lead to more than one solution. That's they're saying the ambiguous case. And that's the one side angle. Anything else?
Where do I go for wildcat time?
Huh?
Is it where?
What question was that had the parallelogram you were talking about?
It was in 5-6 and it was number 9. It was not number 9. It was number 8.
So when I draw a parallelogram, which angle do you believe is 55 degrees there? Probably that one. Okay, and it doesn't matter, but probably that one. So this would make this one, what, 125? Because going back to geometry, these are parallel lines,
Yep.
and those are same side interior angles, so they gotta be supplementary. All right, you got a side length of 9 and 7, okay? It says find the lengths of the diagonals. And this doesn't really matter, but let's say this is my 9 and this is my 7. When I find so here's one diagonal, right? Is that okay with everybody?
Yes.
I got that angle. So I'm looking now at this triangle where this is 55, this is 9, this is 7. I'm trying to find x. So this is the law of sines, so we'll say x squared is equal to 9 squared plus 7 squared minus 2 times 9 times 7 times cosine of 55. And now we'll give me that first dotted diagonal. Does that make sense? Okay. Now to do the second one, the second diagonal, again, if this is 55 and this is 125, second diagonal would be that, right?
Yep.
That 9 and 7, doesn't matter which one is 9 and 7 again. If I want to find that one, I'll just call that d. D squared is going to be 9 squared plus 7 squared minus 2 times 9 times 7, cosine now of 125. In the fact of, people always ask, well, which one has to be 9, which one has to be 7? Well, think about how it's used in the formula. It's 9 plus 7, 9 squared plus 7 squared. It's 9 times 7. Those two things are both commutative in the formula, right? Addition and multiplication are commutative. So that tells me it doesn't matter which one's 9, which one's 7. Okay? Because if you interchange them, you're still getting the same result. I like that. No, the reason I put that one on there is because that one is number 9. Okay? Or let's, instead of doing number 9, let's talk about the one from the practice test, number 10. Okay? When we talk about, and I put a video together. Did you guys see that video?
Yeah.
Okay? Email from the other day, video of what north 60 degrees east means. Okay? That first letter can only be N or S. The second one can only be E or W. That's the way, that's the convention of using directions with angles. Okay? But the way this means is that if I'm looking at going north, that means I'm going to travel north, right? And then it says you're going to go 60 degrees towards the east. North, 60 degrees towards the east. Or go north and then deviate 60 degrees towards the east. So I go north, change my angle 60 degrees towards the east, and I get this red, or not red, greenish gray here. Does that make sense? Okay. That's 60 degrees. Is that okay with everybody?
Yes.
So what's that angle right there? 30. It's a complement, right? Okay. The second boat was going south 50 degrees east. So go south, but now deviate 50 degrees towards the east. So that's 50. So it makes that 40, right? Okay. Now, if you guys know anything about vectors, you could put this vector, you can cut and paste it and put it right there. You can take that vector, cut and paste it and put it right there. And you can
Pardon the interruption. This is just a reminder that all juniors are to report to the cafeteria at the beginning of Wildcat time for the ACT pre-administration. Again, all juniors, you're going to report directly to the cafeteria. All other students, please report to your Wildcat time to pick up your interns. And then after that, if you're interested in attending the Interact meeting, that will be held in the auditorium. Thank you.
All right, so this 70 was not presented in this question, right? The 70 is found by adding those two complements together because that's the angle that's between these two boats' paths, right?
Right.
Now, these 140 and 126 were not given throughout the problem either. They were implicitly given. Instead of giving you the total distance traveled, I tell you they traveled for 3.5 hours at 40 miles per hour and at 3.5 hours at 36 miles per hour. Well, distance equals rate times time will give you those two total distances, right? So after 3.5 hours, these boats come to stops, right here and right there. One's traveling 126, one's traveling 140. They've done it at an angle between them of 70 degrees. So I can find that distance using the law of cosines. Which, like I said, that is the same thing as drawing eventually. So there's boat 1, there's boat 2. If I take that vector and put it there, take this vector, put it there, this would be 70 degrees. That's 70 degrees, okay? The resultant vector, if you guys know anything or remember anything about physics, would be the idea, okay, let's say that maybe there was an object here that we pushed in that direction and at the same time pushed in that direction. Where did it go? It would go like right there, right? Which is the diagonal of, it'd actually be that diagonal right there. Okay? Which we'll talk about more when we get there. But this stuff here, this law of cosines, you remember the other day I said, chapter 5 is trying to build a foundation, build some skills so that as we move throughout other chapters, we don't have to learn this skill and then learn what that chapter is devoted to. Does that kind of make sense? When we start talking about vectors, law of sines and law of cosines, especially law of cosines, we find a very critical point for us. Very critical. What, Chuck?
So what's this?
That's the law of cosines. That's finding the answer.
That's just that one.
No, the law of cosines says. Thank you, you too. The law of cosines is this. A squared is equal to b squared plus c squared minus 2bc cosine. Okay. These are opposite objects, and then b and c are the other two legs. Because the situation that's being presented there is that that's 140, that's 126, this is 70. Okay, so you're thinking cosine because of SOHCAHTOA, right? Cosine for SOHCAHTOA only works with right triangles. This is not a right triangle. Makes sense? You gotta use law of cosines for, well, the side, angle side is given.
Are you going to interact still?
Yep. You guys grab your intervals up there if you want.
Maybe see if Miss Black is here.
Yep.
Tell her wait. Yeah.
He's sick. Yeah. Hey, I already grabbed it. Yeah, but I have to go to the gym first. Or the parent.